أعزائنا الطلاب بنرحب بكم. دايما بنقول ان الشرح هو جزء بسيط جدا جدا من المنهج ومن المقرر. بسيط بحيث ان احنا ممكن نشرح الموضوعات المحاور الأساسية، ولكن بتبقى نقطة مهمة جدا وهي التدريبات، التمرينات، الأمثلة، النماذج المتعددة. هي دي الجزء الأكبر والجزء الأهم والأعمق في المنهج. مقرر الرياضيات أو منهج الرياضيات من المواد اللي دايما بتحتاج إلى حل كتير جدا، وجود أمثلة، وجود نماذج عليها علشان تقدر تتمرس عزيزي الطالب. النهاردة معاك ومع مادة الاستاتكس أو فرع الاستاتكس في مادة الماث هنشرح وهنقدم درس جديد، وتحديدا هو الدرس أو ليسون 4، وهو إن شاء الله هيكون الأخير في المنهج. معانا أمثلة كتيرة جدا ونماذج وتدريبات هنقدمها لك، ونتمنى تستفاد منها طبعا من خلال لقائنا النهارده مع مستر عبد الناصر جابر، خبير الرياضيات اللغات بوزارة التربية والتعليم. مرحبا بك.
اهلا مرحبا بك يا فندم.
زي ما انا قلت في البدايه، فعلا ماث يعني من المواد اللي
طبعا
بتحتاج الى حل كتير جدا، صح
كده؟
كده؟
طبعا طبعا.
سهل ان انت تفهم الرول او الاكسبريشن او الحاجه اللي موجوده عندك، ولكن التطبيق العملي ليها اهم
طبعا
بكتير.
بالايد لازم نحل كتير فعلا.
صح كده؟
طبعا.
تمام. طيب احنا النهارده وصلنا الى ليسون
4. البارت الاخير كمان في ليسون 4 الاكوليبريم، اخر جزء في الاستاتكس. يبقى كده احنا الحمد لله قفلنا الاستاتكس، ويبقى ان شاء الله في حلقات جايه نشتغل solid geometry and probability
ان شاء الله. الاستاتكس من الفروع الجميله الممتعه طبعا في الماس والسهله والشيقه في نفس الوقت، صح كده؟
طبعا طبعا.
اكيد حضرتك كمان بتقدمها لنا باسلوب مختلف. خلينا نبدا معاك
باذن الله.
اتفضل.
My dear students, now we are going to study the part 2 from the equilibrium, and equilibrium means that the body at rest or it balanced. Now we will concentrate about 3 forces. If we have here 2 forces and we have the third one, so if we have 2 forces and these 3 forces here, the body will be in equilibrium only if these 3 forces intersect at one point. It's very important for you. If we have 2 forces and we have force here, must be act with this or connect with these 2 forces to be equilibrium of the body. So concentrate with us now. We have here a very important rule. If a rigid body is in equilibrium under the effect of 3 coplanar non-parallel forces, then the lines of action of the 3 forces meet at one point. We have a drawing here. We have R1, which is force 1. We have R2, force 2. And we have weight. Weight usually affect downwards vertically. And we have here a wall, smooth wall, so the reaction will be perpendicular to it. Concentrate, because it's very important when he say that the wall here is smooth, so the reaction will be perpendicular to this one. And imagine that we have a rough plane here which is ground. If we have a rough plane, not smooth, then the reaction goes everywhere. And it must intersect with the first 2 forces, which is weight, underward, and R, which is horizontal. So reaction of the ground on the to the body will be intersect at D. So concentrate well. For example, if a uniform rod of weight, this is uniform rod, we have BA is a uniform rod here, and its weight equal W here, rests with its NB here on a smooth vertical wall. So the reaction will be perpendicular to it. And with its end A, which is here, on a rough horizontal ground. Then the weight of the rod acts at the midpoint of the rod. Concentrate well, because the weight must be in the middle point or the midpoint of the road AB from the midpoint here downward of the road vertically downwards. Reaction of the wall R1 is perpendicular to the smooth wall in the direction BD. Yes, it is. And we have reaction the rough ground R2, and it goes to the 2 points, or the point of intersection of the two forces. So we have here three forces. One of them the weight downward, and reaction of the smooth wall horizontally on the right direction, and we have R2, which is doesn't goes to vertical, but go to point of intersection of the other two forces. Example, we have a very important example here, so concentrate with me please. A metallic smooth regular sphere of weight 1.5 kilogram weight and radius length equal 25 centimeter is suspended from a point B on its surface by a string of length 25 centimeter. Its other end A is fixed at a point in a smooth vertical wall to be in equilibrium as it rests on the wall. Find the magnitude of the tension in the string and the reaction of the wall. And my dear students, remember that the center of gravity of the homogeneous sphere is its gravical center. Look carefully at this drawing. We have here the ball or the sphere affect its weight downward, and the reaction of the smooth wall here, it's horizontally to right, and we have a string here has T tension, and we have the radius here. Okay, look carefully at me. Imagine that is the wall and this is the ball. Okay, and we would like to put this ball like that. The ball rests on the wall. It's a smooth wall. The body or the sphere, its weight affects downward like that. And the reaction of this ball acts perpendicular to the wall because it's smooth. And we have tension here which affects upward here on the line of this string upward. So we have three forces here. One of them, which is the weight, affects downward, and R1 affects horizontally, and the tension affects upward on the line of the string. So we have three forces here. So concentrate with us to find how can we solve this question. Triangle MAC. Look carefully at the triangle MAC here. We have CM equals what? Yes, it's equal the radius of the sphere. And he told us in the question that CM here equal 25 centimeter. So it's 25. MB equals what? Yes, excellent pupils can say that MB equals 25 centimeter. And he gives us also the length of BA, which is equal 25 centimeter also. So we have AM equal 50. Yes, excellent pupils. AM equal 50 centimeters. MC equal 5. So we can easily, in this triangle, which is right angle triangle here, use Pythagoras theorem to find AC. Yes, AC can find by square root 50 power 2, which is hypotenuse, minus 25 power 2, which is the radius here, So the answer will be 25 root 3 centimeter. So we have the three sides of action or the three lines of action of the forces. AM equal 50, MC equal 25, CA equal 25 root 3. Applying triangular force rule, here we can put the tension in this reaction, in this direction here. The length of MA equal 50 centimeter and AC equals 25 root 3 and CA equal 25 centimeters. By applying the rule of triangular rule, T over 50, this force over its side, equals 1.5, this force, which is weight, over AC, which is 25 root 3, and finally R over 25. So we can make a cross multiplication here to find T. T equals 50 multiplied 1.5 over 25 root 3, and find R also by multiplying 1.5 times 25 over 25 root 3, and the answer will be T, what's the tension, equal root 3 kilogram weight, and R equal root 3 over 2 kilogram weight. Another example for you. A uniform rod of length 100 centimeter and weight 30 Newton is suspended at its ends freely by two perpendicular strings. Their two ends are fixed at a hook. If the length of one string is 50 centimeters, find the magnitude of the tension in each of the two strings when the rod is hinged freely and in equilibrium. Concentrate well, because if you can draw this question, you will solve it easily. So concentrate about drawing. We have here the rod is in equilibrium under the effect of how many forces? Of three forces. Yes, we have this rod, which is BA, and of weight 30 Newton. Look carefully at this. D is the midpoint of BA. Don't forget that. And the weight, sure, it effect downward, vertically downward. Okay? And we have two strings, AC and the other one BC. AC equals 50 centimeter length. CD, what is CD? CD here is a median. Why is it is the median? Because D is the midpoint of BA. And we know from the second prep studying that when we have a median drawn from right angle here in the triangle, its length sure will be equal half the hypotenuse BA. So CD equals half BA. So CD equals 50 centimeter now. So remember that, don't forget that CD equals 50 centimeter. So we have a triangle here, CAD is equilateral triangle, because CA equals AD equals DC. And each angle in this triangle equals 60 degrees. Even measure angle A equals 60, measure angle CDA equals 60 also, because we know from previous studying that if we have a triangle, all sides are equal, then all angles are equal in measure also. So we have here right angle, as he said. If this angle is 60, then the other angle is 30. Yes, the weight 30 Newton act vertically downward in the middle of the rod. The tension is that in the two strings T1, T2 act on AC and BC. They are respectively and interested perpendicularly at C. The same drawing here. CD is drawn from the vertex of right angle to the midpoint of the hypotenuse. So it's half the hypotenuse equal 50 centimeter now. ACE is an equilateral triangle as we said. Measure angle ACD equals 60 degrees. Measure angle ACD equals 30. And by applying Lam's rule now, we have three forces, T1, T2, and the weight 30. The angle between them, the angle between T1 and T2 is 90 degrees. The angle between T2 and 30 equals 90 plus 60, which is 150 degrees. The angle between T1 and the weight equal 90 plus 30, which is 120 degrees. So we divide T by sine 150 and T2 by sine 120 and 30, which is the weight, over sine 90. By using your calculator and making the cross multiplication here to find T1, T1 equals 30 multiplied by 150 over sine 90, and T2 equals 30 multiplied sine 120 over sine 90. So the answer T1 equals 15 Newton and T2 equals 15 root 3 Newton. My dear students, concentrate with the drawing. We have a road, we have a weight in the middle of the road, we have two strings here, and he said that or told us in the given that they are perpendicular. And don't forget about the important thing, which geometrically more than mechanics, CD is a median, and from geometrical that CD median equals half the length of the hypotenuse. So we can go to next example. In the opposite figure, yes, look carefully at this figure. A weight of magnitude K, yes, is suspended by an end of string. The other end is suspended by two strings passing over two smooth pulleys at B and A, B and C, and carries two weights of magnitude 30 kilograms weight and 20 kilograms weight. Find the value of the weight K and the measure of the angle theta in the state of equilibrium. Concentrate with and pay attention with equilibrium here. And look carefully at the following notice. If a string passes through a smooth pulley, this is the pulley, look carefully at it, it's a smooth now, not rough, and stretched on it, then the two tensions in the two terminals of string are equal in magnitude. So we have here 20 weight, and of course because of equilibrium it's equal T2. So then if the pulley is smooth, T2 equal T1, or this T2 is the same. We have T2 equal 20 and this T2 equal also 20. So we have a force here, effect on AC line, and we have 30 here, effect downward as a weight, and we have tension which is T1, and we have a smooth pulley, so T1 equals T1 here, the same tension because the pulley is smooth, so we have T1 equals 30. So we have T2 equals 20 kilogram weight and T1 equals 30 kilogram weight, and we have the weight of the body which is K. We have here the angle theta, and this angle is 60. My dear students, concentrate with me. We will use simple things to explain this for you. If we have, this is represent a pulley. Yes. if we have a smooth poly here. So the movement of the string will be easy and smoothly. The tension here equals tension there, and the body here is weight, has weight. This weight equals the tension here equals the tension there. Okay, it's important for you to concentrate about this. When he mentioned that we have a poly, or smooth poly, and we have a body suspended on it freely, so the weight equals tension, and this sphere here is in equilibrium, so the weight equals tension here. It is equal also tension there. So T1 equal T1 here, equals the same magnitude of the weight. Okay, let's concentrate again with our slides to solve this question. Solution will be, in the previous figure, let the tension in the string be T1, T2 and act in direction of AB and AC as you see. We have here AB and AC, tension 1 and tension 2. Tension 1 equals 30, tension 2 equals 20, and the weight equal K. And the poly are smooth. Then T1 equals 30, T2 equals 20. The body of weight K is in equilibrium under the effect of three forces: the weight of magnitude K and the tension in magnitude T1 and T2. So, by applying what? Lam's rule, which is easy for us. The first force, 30, where is 30? 30 here is a T1 over this angle. This angle is theta plus what? Plus 90. And 20 over sine 60 plus 90. This force opposite to this angle, which is 90 here, plus 60. So 20 over sine 60 plus 90. Do not forget to put the two brackets here. And we have the last force, which is K. K is the weight, and its opposite angle here is 180 minus 60 and theta. So the angle here, 180 minus all of these two angles, 60 plus theta. So simplifying this thing, don't remember, and remember this notice from the previous studying in trigonometry. Sine 90 plus theta equal cosine theta, but sine 180 plus theta equal sine theta. So we will go to this rule now. 30 over cosine theta equals the answer of this equal 40, and K over sine 60 plus theta. Therefore, cosine theta equals 3 over 4, and measure angle theta will be 41, 24, and 35. K equals 40 times sine 41, 24, 5 plus 60. So K approximately equals 39.2107 kilogram weight. It's wrong here. I apologize. Sine 180 plus theta equal negative sine theta. Okay, so concentrate with that, because sine is positive in first and second quadrant. Okay. Equilibrium of a body under the effect of a set of coplanar forces meeting at a point. Example, if we have F1 equals 5i, it's vectors now. We have F equals 5i minus 3j, F2, F3. Prove that the forces F1, F2, F3 are equilibrium. I am asking you, if we have three forces F1, F2, F3, when they will in equilibrium? Let us the answer. R equal F1, F2 plus F3. We add all i's here, 5i plus negative 7i plus 2i and also negative 3 j plus 2j plus j. So the answer here will be 5 minus 7 plus 2i plus negative 3 plus 2 plus 1j equals 0. Surprise. 0 here, that means that the sum of 3 forces equals 0. Remember that if the sum of the 3 forces or resultant of 3 forces equals 0, then the body will be in equilibrium. Yes, excellent. Another example. In the opposite figure, A, B, C, D, the forces of magnitudes, this is magnitudes of the forces, in directions, and he reminds the directions respectively. E is the midpoint of CD, proves that these forces are in equilibrium. Solution. We have here a square, as he mentioned, and we know that square are equilateral polygon. All sides are equal. So from the opposite, we have here 16 acts on AB, 12 root 2 acts on CA, look carefully, and 4 root 5 acts on EA, and you have E midpoint of DC, don't forget, and we have the last force, 20 acts on AD, and from the previous studying we have 16 cosine 0 here, plus 20 cosine 90, plus 12 root 2 cosine 225, plus 4 root 5 cosine 120 plus 80 plus theta. So x equals the answer. Look carefully at that. From where comes 225 degrees? Look carefully. We have here the opposite side of the force. So we have 90 and 90 and this angle. So it's 225 degrees. So x equals 0. Y here? Sine instead of cosine for all angles. So y equals 0. Here x equals 0 and y equals 0. So resultant equals 0. So it will be in equilibrium.
مستر عبد الناصر، سعداء جدا بوجود حضرتك معانا النهارده وشرح جميل ووافي وكافي لماده الاستاتكس. نقدر نقول النهارده ان احنا ختمناها الحمد لله، وده كان اخر ليسون فيها اللي هو كان ليسون 4.
تمام.
شكرا لحضرتك ولمجهودك معانا والله خلال الترم كله.
ربنا يخليك.
شكرا لحضرتك. اعزائنا طلاب الصف الثاني الثانوي، وصلنا معاكم لنهايه الليسون 4 في ماده الاستاتكس، فرع مهم جدا من فروع الرياضيات. انتظرونا في المراجعه ان شاء الله حتى نلقاكم مجددا. شكرا لكم وشكرا لحسن وطيب المتابعه.